Hey friends, Mr. Sanford here. I want to go over some of these 3.0 examples for you guys, and let's just go ahead and kick it off. The reason they are 3.0 is because they are ions, meaning they have a charge. So here's a lithium ion. It has a charge of 1 positive. So we can go ahead and fill in that part of our chart. 1 positive, or positive 1. And we know that lithium is element number 3, so it has 3 protons. What we need to do now is to calculate or figure out how many electrons this atom of lithium has. And we do that by considering the number of proton positively charged particles and the number of electrons negatively charged particles. This 1 positive means that we lost 1 electron. So if we started off with 3 electrons to match our 3 protons and we lost 1, that means we end up with only 2 electrons on this atom. 1 positive, again, means we lost 1 electron and therefore have an excess of positive charge. So now we can draw our atom. Lithium, this lithium ion with 2 electrons, well, we know the first shell can only hold 2 electrons, so we draw those here in the first shell. And that's all the electrons we have, so we can't draw any more. That means this third shell isn't getting used, and we can ignore it. So this atom, this model of lithium, has 2 valence electrons. It has 0 core electrons. There is nothing between the valence and the nucleus. And we used 1 shell to create this model. So we only used 1 shell. Let's take a look at another example. Here is an oxygen ion with a charge of 2 negative. So 2 negative indicates that we gained 2 electrons. So 2 negative is our charge. We can go ahead and put that in there. We gained 2 electrons. So protons, the atomic number of oxygen is 8. If we had 8 electrons and we gained 2, 8 plus 2 gives us 10 electrons that we're going to put into this model. Okay? So we can go ahead and draw that. In the first shell, it can only hold 2, so we put 2 of our 10 electrons. So now we have, of our 10, we only have 8 left. Well, the second shell can hold a maximum of 8, so that means we can put all 8 electrons in the second shell. All right, so there is our model, right in the glare. Good job. So now we can count our core and valence electrons. Valence are in the outermost shell. I have 1, 2, 3, 4, 5, 6, 7, 8. 8 valence electrons. Core electrons are between the outermost shell and the nucleus. So that's this shell. There are 2 core electrons. 8 and 2 makes 10. The number of shells I used to create this model is 2. The first shell and the second shell. Let's look at the you-do examples, and we'll go over the solution to both of those as well. I'm going to skip to the next slide where it shows this. Magnesium ion in the screen. Magnesium has 12 protons. The atomic number is there. The charge is 2 plus. That means we lost 2 electrons. If we started with 12 electrons to match the protons and we lost 2, that means we have 10 electrons. Now we can draw our Bohr model. We have 10 electrons. 2 go in the first shell. And that's all that fit. That's all that can go there. That's the maximum amount. So that leaves us with 8 left over. 8 electrons. Well, the second shell can hold a maximum of 8 electrons. And so all 8 can fit in this second shell. That means there's nothing in this third shell, so we can ignore it. It doesn't impact anything. And now we can count our valence and core electrons. Valence are the outermost shell. That's the second one. There are 8 there. Core electrons are between the valence shell and the nucleus. There are 2 there. And we used 2 shells, again, to make this model. That's right in the glare, but that's 2. Let's look at the last example. Another ion, a phosphorus ion. Phosphorus has 15 protons. The atomic number is 15. It's got a 3 negative charge. That means we gained 3 electrons. If we have 15 electrons to match our protons and gain 3, that means we have 18 total that we can draw. So let's draw those. 18 electrons is what we're starting with. 2 can go in the first shell. Always 2 in the first shell. That means we have 16 electrons left. 8 of them can fit in the second shell. And only 8. So we take away 8. That means we have 8 electrons left for the third shell. The third shell can hold 18. That means all 8 can be drawn in this shell. Valence electrons are the outermost shell. We have 1, 2, 3, 4, 5, 6, 7, 8. Core electrons are between the outermost shell, that valence shell, and the nucleus. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Awesome in the glare. So are these. The number of shells we used to create this model was 1, 2, 3 shells. All right, thanks everybody.